During your stay, take a spin around our rover racecourse and don't miss a visit to Tranquility Base Museum. You can still see Neil Armstrong's footprints near the original lunar module. Those of you in the left cabin must be enjoying the view of planet Earth. Local time is 10 hours past lunar dawn. Ladies and gentlemen, welcome to the moon.
Major funding for Space Age was provided by the Corporation for Public Broadcasting and viewers like you. Additional funding was provided by the National Science Foundation, the Arthur Vining Davis Foundations, the U.S. Department of Energy, and McDonnell Douglas.
Have you ever wanted to pull up stakes and move to a faraway land? You're not alone. I'm Patrick Stewart. Some 500 years ago, a stream of humanity began its flight from Europe towards the shores of an uncharted new world. And centuries later, the promise of gold led to the rallying cry, "Go west, young man," and go west they did by the thousands to settle the American frontier. In July of 1969, a new frontier was opened. To a growing number of would-be explorers, the moon represents the latest land of opportunity for human expansion and settlement. There's gold in those lunar hills, clues to the origins of our Earth and solar system, and maybe enough resources for Earth's first extraterrestrial colony. Enough to justify a return to the moon and beyond. Tradition once held that test pilots made the best astronauts. In 1972, NASA broke with tradition and sent a trained scientist into space, geologist Harrison Schmitt, better known as Jack. On December 11th, he and Commander Eugene Cernan would navigate the spacecraft Challenger to the surface of the moon.
Stand by for pitch over. Oh, are we coming in? Pitch there it is. Proceeded. And there it is, Houston. There's Camelot. Wide on targets. I see it. We got them all. 42 degrees, 37 degrees, to 5,500. Stand by for some dust. Little forward, G. Little forward a little. 90 feet. Little forward velocity. 80 feet. Going down in 3. A little dust. Going down about 2. Very little dust. Very little dust. 40 feet. Going down at 3. Stand by for touchdown. Stand by. 25 feet. Down at 2. Feels good. 20 feet. Going down at 2. 10 feet. Contact. A push. Engine stop. Okay, Houston, the Challenger has landed.
Roger, Challenger, that's super.
Houston, you can tell America that Challenger is at Taurus Littrow.
The Valley of Taurus Littrow was literally a geologist's paradise, and that phrase popped out as when I had my first chance to look out the right-hand window of the lunar module Challenger and see this magnificent valley we had landed in. We had an impression of what it was going to be like from the photographs and the simulations that had been done based on those photographs. But to actually see the brilliantly illuminated slopes in this deep valley, deeper than the Grand Canyon, in fact. The mountains on either side went up to 7,000 feet. A blacker than black sky, brilliant sun illuminating this valley, as brilliant as any New Mexico sun one can imagine. That whole feeling and the three dimensions that one could see really resulted in me thinking this is going to be fun, and it was.
I was strolling on the moon one day in a merry, merry month of December. No, May's the month. May, that's right.
The goal of the Apollo 17 mission was to explore a valley carved out by a huge meteorite impact over 3.5 billion years ago.
Too bad I don't have my skis. Man, I covered ground.
Schmidt and Cernan covered more territory, collected more moon rocks, and spent more hours on the lunar surface than any previous Apollo mission.
Gravity.
Copy the mark. Copy the mark.
Okay.
It's the old boulder rolling trick.
How about getting a soil sample under there?
Don't hit the rover.
3 days of hard work and the occasional frustration.
No. Dadgummit.
Jack Schmidt having a few problems.
Cernan and Schmidt were the 11th and 12th humans on the moon. They were also the last. Before they left, Cernan commemorated the fact.
We'd like to uncover a plaque that has been on the leg of our spacecraft that we have climbed down many times over the last 3 days. And I'll read what that plaque says to you. This man completed his first exploration of the moon, December 1972 AD. May the spirit of peace in which we came be reflected in the lives of all mankind.
A remote-controlled television camera left on the surface recorded their departure on December 14th, 1972. They left behind a moon littered with the remains of the Apollo program, footprints that will last 1 million years in the unchanging environment. The descent stages of 6 lunar modules, 3 moon rovers, 2 golf balls, a hammer, a falcon feather, half a dozen American flags. A network of scientific instruments powered by small nuclear generators once sent streams of data back to Earth until the system was shut down for lack of funding. Both America and Russia sent robotic spacecraft here. Some crash-landed, spraying the ground with electronic debris. And in one poetic gesture, hundreds of small, red Soviet stars. Today, the moon is quiet. No one has ever been back. 36 stories high, capable of 7.5 million pounds of thrust, the Saturn V is the most powerful rocket ever to launch humans into space. Never once did it fail. Children who visit the grounds of Johnson Space Center in Houston, Texas, may never have heard the names Armstrong and Aldrin, or the words, "The Eagle has landed." And if they have, they may not understand why we stopped going to the moon or why we went in the first place.
I believe we should go to the moon. I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
When President Kennedy addressed Congress in 1961, he upped the stakes in a race that had begun years earlier. October 4th, 1957, Sputnik, the world's first artificial satellite, is launched into orbit by the Soviet Union. Suddenly, America is in second place. April 12, 1961. The first human in space, Soviet cosmonaut Yuri Gagarin, orbits the Earth once, then tours his homeland as a national hero.
More tense near the eastern coast.
3 weeks later,
Obscure is up to the
America
Hatteras.
storms the heavens. Launched to an altitude of 116 miles, Alan Shepard enjoys a beautiful view and a perfect landing. February 1962. In a 5-hour flight that takes him around the world 3 times, the first American to achieve orbit is John Glenn.
Affirmative. I am go for the next orbit. Roger, understand. MCC confirms that they are go at the present time. For
Still trailing the Russians in space, America sets a bold new goal. With the Apollo program, the race is on to the moon. Research, development, and testing of new technology consumes the energies of several major NASA centers and 20,000 corporations. By some estimates, nearly a quarter of the work performed is voluntary, unpaid overtime from people so wrapped up in what they're doing, they forget to go home. Whole new sciences are invented and refined. New materials are designed for the rigors of spaceflight and the impacts of Earth. An army of 400,000 people actually lay hand on some element of the Apollo program. Together, they build the most complex and powerful machine the world has ever seen. 3 million pieces of high technology that interact with a cohesion seen only in nature. At a cost of $24 billion, America prevails. Between 1969 and 1972, 12 Americans make a journey of 500,000 miles and leave their footprints on another world. In less than a decade, President Kennedy's vision becomes reality. The space race is over.
We got a beautiful picture of you guys up down there.
But beyond the finish line, the space program lost momentum. Distracted by the Vietnam War, the public had little interest in moon missions. Political support vanished. For Paul Spudis, the Saturn V represents the end of an era.
This is an incredible machine. It lies on the grass here in the hot Texas sun when it should be at the bottom of the Atlantic Ocean. And the reason it isn't is because the last 3 flights to the moon were canceled. I have great pride in the fact that we could once do this. We could once build a machine that could hurl people and machines at the moon. But at the same time, I'm depressed because we're not doing that. Space is big. It's forward-looking. It's future-oriented. It's visionary. It excites people. It excites children. I mean, that's why I got into the business, is because I saw people going to the moon and I saw people flying in space, and I wanted to do that.
A geologist at the Lunar and Planetary Institute in Houston, Texas, Spudis is part of what has been referred to as the lunar underground. A growing number of scientists, engineers, and entrepreneurs share a conviction that a return to the moon should be part of any space program.
There are 4 things that you can do on the moon. You can study the moon as a natural laboratory to understand planetary processes and to study the moon's own history. You can use the moon as a platform to look at the universe around us. You can use the materials and energy, the resources of the moon, both in space and possibly to import to the Earth. And finally, you can live on the moon. You can understand what it takes for humanity to live off-planet.
The moon is the size of the continent of Africa. The moon is an entirely new continent, an 8th continent, that the United States and other people in the industrialized world who wish to do so can make our own.
If space is going to benefit us, it's surely going to be near Earth space. The moon's in Earth's orbit. It's always handy. means trip times are short, means it's somewhat safer than going to things that are farther away. It means that we can get more people there and back in a shorter time.
It's a stepping stone to the rest of the solar system. If we want to go to Mars eventually and explore our solar system, we've got to learn how to live and work in an alien, hostile environment.
I see going to the moon as inevitable, and the only problem is whether it will be in my lifetime or in this century or by this country.
No longer is the moon merely a political pawn between two superpowers. Today, Japan's interest in a return to the moon is strictly business. Plans for a 21st century lunar base are underway in Tokyo at Shimizu Corporation, the largest construction company in the world. Shimizu executives anticipate rewarding new markets in the development of space. They are banking on the future.
At first, few people will go back to the moon to learn how to cope with the harsh conditions, to understand what kind of manufacturing will be possible. In the long run, we must learn to use local materials, so it may take some time, but eventually many people will be living on the moon.
Natural Space Station, laboratory for space research, home to human settlers. A new vision of the moon is taking shape. It is a far cry from the heavenly body that once inspired awe and reverence, witchcraft and lunacy, passion and romance. Since Apollo, we can't quite see the moon in the same way.
7, 6, 5,
The best and the brightest of American science and technology carried the Apollo astronauts into space. With them went the hopes and dreams of an entire world. In a sense, we all went to the moon.
Okay, Houston, we're maneuvering to the burn attitude. Roger, we copy that.
On the Apollo 12 mission, Alan Bean and Charles Conrad would be the second team to land there.
Anything else, Pete? We're trying all these things that we didn't have in Gemini, like toothpaste and shaving, and we're really having a ball up here.
Roger. All dressed up and no place to go.
Oh, we're going someplace. We can see it getting bigger and bigger all the time. All three of us are plastered to the windows looking.
They had an ambitious goal, to land near the Surveyor, a robotic probe that had been sent to the moon nearly 3 years earlier to transmit photographs of the lunar surface.
Hey, Houston, the sim's running pretty today.
On the way there, Conrad had his doubts about the plan.
It wasn't supposed to be, but obviously the success of the flight depended on finding the surveyor. And so people always say, what did you worry about? Well, I mean, that's what I worried about. I worried that, one, I wouldn't find it, and then it was never really clear to me how the scientists knew exactly where it was either.
Okay, got the old camera running.
Conrad couldn't wait to get down on the surface.
Down to the pin. Okay. Man, that may have been a small one for Neil, but that's a long one for me. I gotta take it easy and watch what I'm doing. Boy, you'll never believe it. That's what I see sitting on the side of the crater. The old surveyor, huh? The old surveyor, yes, sir. Does that look neat? It can't be any further than 600 feet from here.
Later, Conrad and Bean retrieved Surveyor's TV camera and mechanical scoop, both remarkably pristine after nearly 3 years of exposure. More importantly, the pinpoint landing proved scientists could safely land a spacecraft on a target 250,000 miles away. Conrad and Bean set up the first station of a science network to measure the moon's magnetic field, surface gases, the output of energy from the sun, and the occasional weak moonquake. Powered by a small nuclear generator, the instruments worked for years. Each Apollo mission added to the global picture. The 6 landing sites included mountainous areas and lowlands.
Oh, spectacular. Just spectacular. Wow.
On the last 3 missions, rovers provided greater mobility. Reaching a top speed of 10 miles per hour, the electrically powered moon buggies allowed astronauts to explore up to 6 miles from their landing site and to collect hundreds of pounds of rock and soil samples. With each mission, a new science station was added to the network.
I guess so. Keep it nice for the next guy. Okay.
Cores of surface materials were drilled. Over 30,000 photographs were taken. Every moment of the astronauts' time was painstakingly scheduled for science activities. At the height of the Apollo program, a staggering 9 million instrument readings a day were beamed back to Earth, data which scientists continue to analyze today.
I put a mark in the deck. Here it is, right there.
Our knowledge of the moon is deeper and broader than for any other object in the solar system, except Earth. Geologists like Paul Spudis are reconstructing the history of the moon and have formulated a new theory about its origin.
Now, before the Apollo landings, there were 3 ideas of lunar origin. The idea was that the moon and Earth formed jointly. The other idea is that the moon was captured. It was formed in a different part of the solar system and captured into Earth orbit. And finally, the idea was that the moon fissioned from the early Earth, spun off when the Earth was spinning very rapidly early in its history. Well, we found out from Apollo none of those ideas are really tenable. And in fact, we needed Apollo to give us an appreciation for the importance that impact plays in early geological history. And now the current favorite idea for lunar origin is that a giant planet hit the Earth 4.5 billion years ago, and that effectively splashed material into Earth orbit. And that material accreted very rapidly to form the moon.
The early solar system was a chaotic place. Hurtling through space, a planet the size of Mars struck the Earth. So great was the impact that part of our planet's surface was melted and ejected into space. Some material fell back to Earth. Some remained in orbit. Over tens of millions of years, the orbiting debris coalesced into a new celestial body. And the moon was born. If the theory is true, then the moon is indeed the 8th continent, a chip off the Earth's block. By 4.5 billion years ago, the geometry of the Earth-Moon system was in place. At first a molten sphere, the moon soon began to cool. Meteorites relentlessly pelted its surface. Around 3.8 billion years ago, the bombardment seems to have reached a cataclysmic peak, leaving the huge craters that are still visible on the moon today. Then, the violence subsided. For millions of years, lava welled up through cracks in the crater floors, creating the smooth, dark areas called maria. A steady rain of lesser impacts pulverized the surface into powdery soil. Little else has changed in the last 3 billion years. Today, the moon is a dead world, a time capsule, each crater a tick in the geologic clock. Its battered surface preserves a record of our solar system's violent birth and the evolution of the planets. This window on the past has led to a profound insight. The events that left their mark on the moon must have shaped its planetary partner as well. The primordial Earth was showered with meteorites. Some say this may have set up the conditions that allowed life to begin. But most traces of this early time are gone. Unlike the moon, the Earth evolves. Continents shift and collide. Geology is erased and rewritten. Scientists suspect that life has been shaped by bombardment from outer space, by impacts powerful enough to disrupt global climate and trigger mass extinctions. Such catastrophic events have been linked to the demise of the dinosaurs some 65 million years ago. One theory holds that periodically, about every 26 million years, meteorites wipe out most life on the planet. Fossils alone cannot prove the point. But a pattern of periodic impacts on the moon, coinciding with mass extinctions on Earth, would lend credence to the theory.
Just like plaster. I was going to say like cement, yeah.
So the idea is that you would go to the moon, you would look at a large variety of craters on the surface that have formed since about 3 billion years ago, collect impact melt rocks from them and date them. And that way you could resolve this question definitively. Is there a periodicity in the cratering record or not? So that's one example of where studying craters on the moon actually has fairly profound implications for the history of life on the Earth.
Scattered like fossils across this landscape are clues to the origin of life and the evolution of creatures bold enough to dream throughout the ages of traveling to another world.
Boy, is this a neat way to travel. Isn't it great? I like this. I like to skip along. But me, boy.
In 1902, Frenchman Georges Méliès produced the first film to depict spaceflight. His Voyage to the Moon was the biggest box office success of its day. Fanciful as it may seem, the film reflects the confidence of the industrial age. Given the march of technology, why shouldn't humans someday mount an expedition to the moon and marvel at its picturesque views?
Another interesting sight, Houston. I can look straight up and see our good Earth back there. Ready?
When we finally went to the moon, it was in much the same spirit as a camping expedition, equipped with all the oxygen, water, food, and fuel for 2 astronauts to live on the lunar surface and eventually take off from it. Space suits and spacecraft were designed for one use only. And on Apollo 15, Dave Scott and Jim Irwin unloaded the first of 3 rovers that would be left behind on the moon.
Keep it taut. Easy, Jim, easy. Okay. Here, let me help you. I'm going to move the TV camera because it'll save us time if we don't have to tell you what we're doing. Okay.
From launch to landing, each mission was controlled by a command post 250,000 miles away. Lunar advocates see a return to the moon in a different light.
Well, settling the moon is something that occurs after an exploration. If you look at the West, you had the mountain men go off, and then what happened next were the traders who kind of traded with the mountain men, and then you had the forts that came along and protected the traders, and then you had the settlements build up along the forts, and there was kind of a progression in a sequence. And I've argued that the Apollo astronauts represent the mountain men, as it were. They represent the legends and the mythical beings, that where we are now is to try to put down some roots and some permanence.
If we're to do anything other than visit the moon sporadically and maintain a base there, as we do today in Antarctica, if we are to indeed grow and flourish there, we must develop the capability to live off the land.
Water, shelter, hunting grounds, fertile soil. Such are the resources settlers have sought all over Earth. What does the moon have to offer? No life has ever sprung from this surface. Days and nights last 2 weeks each. Temperatures soar to 260 degrees Fahrenheit and drop to minus 270. Cosmic and solar radiation sear the land.
I want to watch this.
Here, the laws of nature rule a hostile and alien world, as astronaut Dave Scott so clearly demonstrated.
Well, in my left hand, I have a feather. In my right hand, a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago, who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that?
In this vacuum, there is no atmosphere, no weather, no sound. Because the moon is smaller than the Earth, its gravity is only 1/6 as strong. A fully suited Apollo astronaut would tip our scales at 360 pounds.
Off the ground, one more. There we go.
On the moon, he weighed a mere 60. All this conspires to make the loose soil a serious nuisance.
Well, everything's getting awful dusty. Boy, everything is stiff. Everything is just full of dust. There's got to be a point where the dust just overtakes you and everything mechanical quits moving.
One astronaut would say his dust brush was his most important tool. Any disturbance of the soil lifts a spray of particles which tend to cling to anything they encounter.
Can I change your oil?
Including camera lenses.
Thank you, Dino. It looks much better.
It's hardly a Garden of Eden. And yet this sterile world has much to offer if you know what to look for.
Well, I think the moon's reputation for being barren is accurate by Earth standards, but not by planetary standards generally. I think it also helps that I happen to be a chemist, so I think in terms of what chemical elements are available, we can always make what we need from them, and of course all the elements are on the moon. The big resource that the moon has in terms of materials, of course, is the ubiquitous lunar soils. They're all over the place. For example, within a cubic meter of lunar soil, you have all the carbon, hydrogen, nitrogen, oxygen, and other constituents you'd need for a lunch for 2 people. You can make 2 full-size cheese sandwiches. You can have 2 12-ounce sodas. You don't even have to cheat and use sweetener. You have enough for real sugar. And you can have a couple of plums and you'll still have everything but hydrogen left over. Everything that we want is there, it just isn't there in the forms that we're used to using here on Earth.
The challenge is to unlock the moon's resources. Haskin is developing extraction techniques. He chemically simulates a tiny drop of lunar soil. Electrodes are inserted. In a furnace heated to 2,600 degrees Fahrenheit, the sample is melted. Electricity flows between the electrodes and separates the soil's components. Iron and silicon will collect at one electrode. Bubbles of pure oxygen are released and will collect at the other. This basic experiment shows that simple principles can be applied to retrieve valuable resources on the moon. The production of oxygen could become a lunar colony's key industry, providing both life support and propellant for transportation. Metals derived on the moon could be used for manufacturing and repair of support systems. There are riches to be mined in the lunar soil, but the technology to do so must first be developed on Earth. That's the hitch. Nearly half a ton of rocks and soil were returned from the moon. It is treated as the rarest, most precious material on Earth. NASA distributes only minute amounts to researchers. All common elements exist on the moon, but some have combined into minerals unknown on the Earth. lunar soil contains a high proportion of glass formed when meteorite impacts melted the surface. The tiny beads can make the ground slippery, as the astronauts found out.
Further down. There you go. Uh-oh. Ah, rat. Okay. Up, here we go again. Give me a help.
Stacy, give it a slight rotation clockwise as you're lifting out.
Okay. Stay there. Stay there.
To design equipment to process lunar soil by the ton, to test a hunch that moon dust can be turned into concrete or a fertile plant-growing medium, how could anyone succeed, limited to a thimbleful of the real stuff? The answer may be in our own backyard, in a deserted quarry near Duluth, Minnesota. Geologist Paul Weiblen studied the first Apollo samples in 1969. Years later, he was struck by their chemical similarity to these rocks. They're the closest terrestrial match to moon rocks yet identified. To come up with a reasonable substitute for the powdery lunar soil, Weiblen had to take matters into his own hands. In the course of an afternoon, he accomplishes what took 3 billion years of meteorite showers on the moon. Equipment once used to process iron ore pulverizes the rocks. To simulate the intense heat of an impact, the soil is run through a plasma reactor at temperatures up to 5,000 degrees Fahrenheit. The end result is called Minnesota Lunar Simulant, or MLS. It's not a perfect match of lunar soil, but its similar bulk chemistry, mineralogy, and microscopic beads of glass make MLS an important research tool.
I'm particularly interested in this work on simulants because it provides a way of doing studies now that will enable future people on the moon to use the lunar materials for plant growth, to recover oxygen, with all the mistakes having been made first on Earth.
Minnesota Lunar Simulant is available to researchers by the kilogram for a nominal fee. As interest grows in developing lunar industries, orders have come in from around the world. At Shimizu Corporation, engineers use MLS to experiment with lunar concrete. Every pound of supplies launched from Earth costs something near its weight in gold. Learning to build with local materials will be the only viable solution for construction on the moon. Stress tests show the simulated lunar concrete to be at least as strong as the terrestrial variety. But making concrete on the moon will require the development of another resource, lunar water. At the University of North Dakota, researchers have devised a way to get water out of rock. They heat lunar soil simulant to 1,600 degrees Fahrenheit, then introduce hydrogen into the system. As the gas flows through the soil, oxygen is released to combine with the hydrogen. The resulting steam condenses into water. Processing lunar soil may look easy, but it means generating high levels of electricity and heat on the moon. At McDonnell Douglas Space Systems Company in California, engineers have found an innovative solution. They routinely melt lunar soil simulant in a graphite mold at over 2,000 degrees Fahrenheit, but they use no electric furnace. They harness the oldest source of energy around. In the 1980s, McDonnell Douglas developed massive solar concentrators as part of a program on alternative energy. Today, these seem a promising technology for the moon. The mold is mounted in the center of the concentrator. Sunlight is focused on it. In only 20 minutes, the soil inside reaches 2,200 degrees and melts. On the moon, where there is no atmosphere, the sun is even more powerful. The mold is left to cool overnight. 24 hours later, it is still warm to the touch.
See if it even opens up.
The experiment produces a tough, ceramic-like material that is nearly twice as strong as concrete. Someday, materials like these could be used to build habitats or to pave the roads to lunar cities. There is gold in those hills, perhaps enough to sustain a lunar colony. But there are other reasons that may drive us back to this frontier. For ages, humans looked up at the moon and could only dream of reaching it. Soon, we may find ourselves gazing up from the moon itself to explore the universe as never before.
Maybe a core. It's right in the middle.
On the Apollo 16 mission, astronaut John Young set up an ultraviolet camera to provide the first astronomical observations from the moon.
Outstanding. You did a good now, satellite.
He took photographs showing the Earth's upper atmosphere and the outer reaches of its magnetic field. He also photographed ultraviolet radiation in the Large Magellanic Cloud, a nearby galaxy. The view was unlike any possible from Earth. Some astronomers begin to see the moon as an ideal platform for observing the universe. The Apache Point Observatory in Las Cruces, New Mexico, is built of lightweight materials with simple working parts.
There we go. Good.
It is also remote controlled by Jack Burns, an astronomer at the University of New Mexico over 100 miles away. Burns sees Apache Point as a prototype for a lunar observatory controlled by astronomers on Earth. But he also has a grander vision for astronomy on the moon.
The moon, for our purposes in astronomy at least, is a dead world, geologically speaking. The ground is extremely stable. There is 8 orders of magnitude less geological energy on the moon than on the Earth. Now that's important to be able to do what's called optical interferometry, to be able to take several individual optical telescopes, link them together as a single, very powerful telescope to look out at the cosmos with extremely high resolution. We can't do that from the Earth, not only because of the atmosphere, but also because the ground is very unstable on the Earth.
An array of optical telescopes, several miles in diameter, could yield fantastic resolving power, up to 1 million times better than anything possible on Earth.
Looks like
But even a modest lunar observatory could perform valuable study.
Once again, looks like most of the... If we had a lunar-based telescope, then we'd be able to zoom in by several factors of 10 more than what we've got here and really look in detail at where these stars are forming. One of the real exciting parts, though, of these new telescopes will be the opportunity to potentially detect other planets in other parts of our galaxy. That's the first step in being able to see whether or not life on other planets and other worlds is a real possibility.
For all our probing of the night sky, we have yet to find a single planetary system like our own. Observatories on the moon will join the ongoing search, scanning the heavens for telltale signs of planets orbiting a distant star, cryptic but intelligent signals that will tell us, you are not alone. The moon holds a grand vision for the future, full of hope and promise. But for now, in the late 20th century, we remain earthbound. How do we get back?
I think our approach to return to the moon cannot be and should not be thought of as one big mission. What we really should think of it as is recreating an infrastructure, a transportation infrastructure, like an interstate highway that we once possessed. We had all those elements. They could have been modified and upgraded a little bit with today's technology, but we, the United States, owned a lunar transportation system. We know how to do it. Once we recreate it, we will have the capability to do any number of missions at relatively small additional cost, and indeed, we will have much of the capability we need to go forward to Mars.
During Apollo, each launch was separate and unique, each a one-shot expedition. Lunar advocates propose a different approach. First to return to the moon will be satellites and robotic craft to map minerals and resources and determine the site for the first lunar outpost. The first crew would be equipped for a stay of several weeks. Their landing would follow that of a cargo ship containing a habitat, life support, and science lab. Teams of specialists would rotate periodically. Geologists would explore. Engineers would develop new technologies. Construction robots would be controlled by operators miles away, perhaps even on Earth. Sparing human workers the dangers of prolonged exposure to the harsh environment, robots would assemble the building blocks of a lunar base. Environmental engineers would master the art of recycling precious air and water in closed-loop systems. Manufactured directly from lunar soil, huge solar panels would convert light into electricity. Solar power collected on the moon could even be beamed to an energy-hungry Earth to become the first extraterrestrial import. The moon might also provide another energy resource. Helium-3, a rare isotope present in minute amounts on Earth, but mineable in the lunar soil. In the next century, scientists hope to develop new fusion technology for more efficient nuclear power. Reactors fueled by helium-3 imported from the moon could provide clean, safe nuclear power. Commerce between Earth and the moon could build financial independence for a lunar colony. Eventually, humans would bring the seed of life to the moon, creating habitats where plants recycle water and oxygen just as they do on Earth. Some say a lunar colony could ultimately become self-sufficient as new forms of farming and space agriculture are developed. In a distant future, some see the moon as a welcome oasis for workers assigned to duty on space stations and as a supply post for missions to Mars and beyond. Today, not a single official dollar has been committed to this vision. To some, it may even seem far-fetched. But stranger things have come to be. In the 1930s, a film called Trip to the Moon depicted one man's vision of the future. Konstantin Tsiolkovsky, a Russian schoolteacher, had dreamed of space travel all his life. A team of daring explorers traveled by multi-stage rocket.
Okay, the first stage was very smooth, and this one is smoother.
They mastered the control of complex technology.
Houston, Apollo 11, Star 40 has just disappeared now in the sextant.
They enjoyed the thrills of weightlessness. Precisely on course, they approached the moon with trepidation. Then they landed in an unusual vertical configuration.
Contact light. Okay, engine stop. ATA at a descent. We copy you down, Eagle.
Human intelligence may fulfill itself in space or discover its limits there. Are there limits to technological progress? Are there limits to our imagination? Perhaps this is the one great lesson we have learned from going to the moon. Given the courage to dream and the will to achieve, we can control our future.
I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
Ladies and gentlemen, we hope you have enjoyed your visit to Tranquility Base Museum and that you found the historical presentation inspiring. Should you find yourself pining for those early days of lunar exploration, just remember, even though the moon has become a familiar and comfortable place, the frontier is still out there, just beyond our reach, just beyond our wildest imagination.
Our journey into space has led us back to planet Earth. With space technology, we now explore our planetary home. With new perspectives, we begin to chart a hopeful course for its future. Mission to planet Earth. The next episode of Space Age.